This is Group 2 for the virtual collaborative discussion of Chapter 5, and our group is gonna discuss about the diffuser. And here's the schematic diagram of the diffuser. There is an inlet across the boundary of the diffuser and there's an outlet. The diffusers are shaped like this so that they can cause large changes in the fluid velocities and the kinetic energies.
Next, what is the function of diffuser? The function of diffuser, it is a device that will increase the fluid pressure by decreasing the velocity, means by decreasing the kinetic energy. So here we can see that this diffuser is opposite to the nozzles. A diffuser is a gas or liquid flow passage of varying cross-sectional area, where at the inlet diffuser, the pressure is low and velocity is high. Meanwhile, in the outlet of diffuser, we achieve the high pressure and low velocity. From the figure below, we can notice that the cross-sectional area of diffuser decrease in the flow direction for supersonic flow and increase for subsonic flow.
Next is the applications of diffuser in real life. Due to its function, it is mostly applied to spacecraft, jet engine as well as rocket. For example, in jet engine, diffuser is one key component of the gas turbine combustor following the compressor. It is designed to decrease the velocity and the kinetic energy of air and increase its pressure instead. In other words, its primary function is to slow down the airflow delivered by the compressor in order to promote efficient combustion and avoid large total pressure losses.
This part is about tutorial question. The question is, refrigerant 134A enters a diffuser steadily as a saturated vapor at 700 kPa with a velocity of 140 m per second, and it leaves at 800 kPa and 40 degrees Celsius. The refrigerant is gaining heat at a rate of 3 kJ per second as it passes through the diffuser. If the exit area is 80% greater than the inlet area, determine the exit velocity and the mass flow rate of the refrigerant. From the question, information that can be gathered are as stated below. And let's make assumption that diffuser is in a steady flow system and a single stream. Thus, from the conservation of mass formula, which is M in is equals to M out, and which is equivalent to rho AV1 equals to rho AV2. Rho is 1 over specific volume. Therefore, from table A13 and A12, we can find the specific volume of 800 kPa at 40 degrees Celsius and 700 kPa for specific volume. Here is the calculation to get the final velocity.
In B, the question wants us to find the mass flow rate. From the previous question, we found that the final velocity is 71.54 m per second. From table A12, we found that at 700 kPa, the initial enthalpy H1 is 265.08 kJ per kilogram. And from table A13, we found that at 800 kPa, 40 degrees Celsius, the final enthalpy H2 is 276.46 kJ per kilogram. Heat is gained by the diffuser, therefore it is used to find all energy in. Heat gain is at a rate of 3 kJ per second. By using the equation of deceleration in diffuser, where all energy in is equal to all energy out, we can find the mass flow rate. The final mass flow rate would be 0.725 kg per second.